Well, sir, we will start.
Please.
Honorable Dr. Abhay Khandagre, sir, our college principal, Honorable Dr. Arvind Brungle, sir, dear delegates and participants, a very good afternoon to everyone. I am Anand Hipparkar, faculty member of S.M.Joshi College, has a special pleasure in welcoming everyone within the country and abroad in the one-day international webinar organized by Department of Zoology, S.M.Joshi College, Padapsa. A very good afternoon, Dr. Khandagale, sir. Sir, a very warm welcome in S.M.Joshi College platform of this virtual webinar. I extend a very warm welcome to our principal, sir, as well, and the delegates. We are here today to inaugurate a one-day international webinar on COVID-19 and dengue vector prevention and control. As we know, the topic is so relevant in the present pandemic situation as well as the ongoing rainy season. Hence, our dynamic principal, Brungle sir, and the Department of Zoology made it a point to organize a webinar on such a relevant issue. Dear friends, let's now the proceedings of the webinar. To start with, I would like to request
service participant. Pracharya pani.
Hello. 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 Hello.
हॅलो सर, आवाज येतोय सर? तुमचा म्यूट आहे बहुतेक सर.
Hello.
येस, हो येतोय सर आवाज.
ओके. मी करू सुरुवात मग?
हो सर, हो सर.
Good afternoon, one and all. I am Dr. Arvind Burungle, Principal of S.M.Joshi College, Adar, sir. Welcome to my college and in the international webinar. I am glad to announce that the Department of Zoology has chosen very relevant topic for the international webinar. The topic of webinar is COVID-19 and dengue, vector prevention and control. Welcome one again. Respected dignitaries, Honorable Abhay sir, and all the participants. My college is run by one of the largest educational institute in India. Its name as Ray Shikshan Sanstha, Satara. In my college, there are 6,000 students studying in various professional and non-professional degree and postgraduate department. We have a research center in chemistry. My faculty have dedicated and research oriented. Our college always involved in several socially useful activities. The present webinar is one of them. I wish the webinar best. With these few words, I stop here. Thank you. Thank you very much. Anand sir, please continue. Anand sir. Hello.
Yes, thank you so much, sir.
Yes.
Thank you for this wonderful introduction. Well, now I request Dr. Pandarbale sir, Head of the Department of Zoology, to introduce the speaker of the first session, Honorable Dr. Abhay Khandagade sir. Over to Dr. Pandarbale sir.
Hello. Welcome all the participant friends, colleagues, researchers, academicians, and others. It's my pleasure to introduce today's webinar speaker, my friend, Honorable Abhay Khandagade sir. He is MSc PhD in zoology. He has 26 years experience in teaching. He presently working as a principal of Professor Ramkrishna More, Arts, Commerce and Science College, Akurdi, Pune. He is a chairman of Board of Studies in Zoology of Savitribai Phule, Pune University. He is also a member of Academic Council of Savitribai Phule, Pune University. He has completed 3 major the topic he had chosen in he had chosen integrated approach to combat COVID-19 pandemic. So I request Dr. Abhay Khandagade sir to start his contribution to the audience. Thank you.
Thank you, sir.
Hello.
Yes, hello. Yes,
Yes.
thank you, sir. I hope I am audible.
Yes, sir, sure.
Yes,
Yeah, yeah.
thank you. Thank you so much. Before I start with my talk on strategies to combat COVID-19, it is a proud moment for me to get associated once again with the Rayat Shikshan Sanstha's S.M.Joshi College, Hadapsar. I think this is the second time I'll be speaking on occasion of some seminar or a webinar as such. So at the very outset, I would like to thank the principal of this college, Honorable Burungre sir, the entire team, organizing committee, Department of Zoology, and my friend Pandrabhay sir for inviting me over here. It was few days back. It was few days back when we had a word about this organization, and then I said, well, COVID-19 is something for which many things are not known. But still, we will have to make this a good looking program, an awareness sort of program. And so I readily agreed upon to speak few things about COVID-19 in the very first session. So with the permission of the Honorable Principal and the organizing committee, I would like to share my screen and start with the presentation. I hope the screen is visible to all.
Yes, sir. Yes.
Underboy, sir?
Yes, sir.
It's all.
Yeah,
It
yeah.
is going on.
It's visible. The screen is visible.
Yes, yes.
Okay.
Yes, sir.
Thank you. Thank you. So let us go on with this topic. The title of this topic is Integrated Approach to Combat COVID-19 Pandemic. Well, this would be the summary of my talk, for which I'll be taking next 40-45 minutes. So to summarize my talk, we'll first speak about virus, then in general about the life cycle of virus and few strategies of coronavirus and how this particular coronavirus propagates. The third point would be brief history and some facts of corona. The next one would be knowing the COVID-19. And the last point would be the integrated approach to fight back corona. So let's start with, so this is what we have. The very first concept is about viruses. So then what comes to our mind is what basically is a virus, or what are viruses? Now in this case, if we see, viruses are the most common biological entities on earth. They are most common, though the word virus nowadays is less known in terms of biology than it is known in terms of IT and computer. Everyone who hears the word virus basically, first of all, thinks about something to do with computer or internet, something of that sort. But let me tell you, it's the most common biological entity on the earth. Experts have estimated that there are around, well, I am sorry, I cannot read out this figure. It's a huge figure. But these many are the number of viruses on the face of earth. They are nature's own nanotechnology. They are their own, in their own, they are molecular machines with sizes on a nanometer scale. They are equipped to invade the cells of other organisms. And this is what is something that is most devastating about viruses. They are equipped to invade the cells of other organisms, and they hijack them to reproduce themselves. So viruses have a tendency, have an inherent potential to infect other cells. Once they infect other cells, they will take over the control of the cell, and at the expense of the host cell, they will start preparing their own progeny, their own generation. So this is what is something which is very, very interesting about viruses. The next one, what we have is, while the great majority are harmless to human, some of them make us sick. They are deadly even. This is quite soothing statement. Majority of them are harmless to humans. Just understand, there are millions and millions of viruses, and majority of them are harmless to human, and so we are basically saved. And the ones which for which we are not compatible with, they will cause certain sort of problems to us. So this is what we feel about these viruses. Okay, the next very important question that strikes our mind, are viruses alive? Now, this is something which is debatable, but let us see. Viruses will rely on cell to survive and reproduce. So viruses can survive and reproduce only if they get a living cell, because they can't capture or store energy for themselves. Viruses cannot capture energy, neither can they store energy. So for their energy requirements, they have to rely on other living cells. So often they are referred to as ultra microscopic obligatory parasites. Outside a cell, these viruses, they will wrap itself into an independent particle which is called virion. And this virion can survive in the environment. Again, this is important for certain period of time. Outside a living organism, they won't be there for the whole lot. Only for certain time they would be there. Okay, which means it remains structurally intact and is capable of infecting suitable organism if one comes in its contact. And the last concept is, when a virion attaches to a suitable host cell, this depends on the protein molecule. The protein molecules on the surface of the virion and on the surface of the cell will help in the attachment of the viral particle to the cell. Now the next step is, they will penetrate. Once they penetrate, they will hack the cell. Once they hack the cell, then they will produce more virons. And these virons will come out of the cell, usually destroying it in this process. So they will destroy the cell in which they are formed. They will come out. Once they come out, they'll go and infect other cells. So this is how it basically works. So once it is outside the cell,
माझी इच्छाच नाही तुझ्यासोबत बोलायची.
hello. Well, so this is something about the viruses. The next point we'll be taking is virus structure. So these are some common viruses and their structure. This is an HIV virus. So can you see this? Here what you have is a glycoprotein on its coat, RNA as the genetic material, plus it is equipped with a special enzyme called reverse transcriptase This is the enzyme by which this RNA will get converted, will get metabolized into an DNA, and then they'll produce their own proteins and it will go on. The next you have is a bacteriophage. Bacteriophage, in simple words, is a virus that infects bacteria. Virus that infects bacteria. This is how it looks, a lunar model, satellite-like. It has got a head in which there's a DNA, it has got a tail and some tail fibers, with the help of which it will settle on the bacterial cell and infect. Then we have a most common looking influenza virus, common in these days. Now again, it has got a glycoprotein coat and then it has got a capsid. It's an RNA virus once again. Then we have adenoviruses. These adenoviruses will have DNA as genetic material, capsomeres and glycoprotein coats around it. Then we have the most common one, TMV, the tobacco mosaic virus, plant virus, wherein you can see it has got a capsid and RNA as genetic material. And then we have the last one, the structure which I wish to show you is Ebola virus, which was again very much known for the epidemic that it had caused. It is a long, slender looking as a polymerase enzyme, RNA as genetic material, and a lipid membrane once again. Let us see some common differences between bacterial structure and viral structure. At the very first, let me tell you that these viruses are very much small as compared to the bacteria. Bacteria, we get them in some particular shape and size, rod shaped, comma shaped, something with a flagellar or a ciliated looking structure. So these are the common structures of bacteria. While if we look into viruses, they have got typical structures which we have explained here. So this is the HIV, this is the hepatitis, this is Ebola, this is bacteriophage, influenza, and the adenovirus. This is the life cycle of a typical virus. What I have selected is an influenza virus. So if we take this influenza virus as an example, it has got a viral envelope and RNA, which is shown in a red color over here. So this virus will first have to come in contact with the epithelial cell, especially in the respiratory tract, and then it binds to the receptor molecule that are present on our cell. This is really very interesting. So these particles are the viral particles. This is the receptor molecule where it binds and then it gets an entry into the cell in the form of an membrane bound structure. We call it as endosome, and the process is endocytosis. Then this endosome coat will further be uncoated. It will be removed and the RNA comes out, enters into the nucleus, undergoes replication. So we have a viral RNA here undergoing transcription, packaging itself, making, before that, it will make its own proteins here. And then these proteins and the RNA together will undergo packaging and new viral particles will be formed. These viral particles will now come out of the cell, thereby destroying this entire cell. So this is the progeny, the newly formed viral particles, which in the second phase will go and infect several other cells. So it will be an exponential growth of these particles. Well, coming down to our COVID-19, the coronavirus, if we see, this has been taken from Nature, recently published on May 7th, 2020. This is how the virus looks like, and what is most powerful about this virus is the power spike. This is the spike protein. So this virus is now being provided with the spike proteins. They have also got some membrane proteins and an RNA inside. This is the cell, this is our cell, and the cell membrane has got a a receptor where you get an efficient binding. So this viral particle will bind with the receptor of this cell. Once it binds here, then on our membrane, we have got some enzymes like furin or TMPRSS2. These enzymes will further break this and bring the viral particle, the viral membrane, in contact with our cell membrane. So this fusion peptides are again important here. These are the fusion peptides which will be coming from here. And now what happens is these two membranes will be fused. Let us see how it happens. Once these two membranes are fused, this virus, which has this blue colored RNA, it's shown in blue, will get an entry into our cell. So fusion will allow the virus RNA to enter into the host cell. Once it enters into the host cell, it will immediately undergo, through its various phases, will undergo what is called as translation. It will produce proteins and, of course, RNA replication. So these proteins and this RNA will be getting prepared inside our cell. And so we are using a word, the foreign RNA hijacks the host cellular machinery. So the entire development of this virus takes place at the expense of the host cell, and it will prepare its own particles. Once the particles are ready, they are assembled, they are ready to be ejected out, and now the cell will be killed, the viral particles will go out, and they are ready to infect other organism cells or cells of the body. Let us go back to the history of this virus, which is quite interesting. Now, we say not much is known about. Veterinarians were puzzled over a feverish cat with an enormously swollen belly. This was the symptom, this was the animal, and the German veterinarians were puzzled, like these symptoms are because of exactly what. So the reason of the manifestations were not clear. Now let us see, this is now thought to be the first reported example of coronavirus. So this is now thought to be the first, that was in 1912, and in 1912 it was not known that it is because of a virus. Now these coronaviruses were known in chickens to cause a disease or to cause infections in the bronchi. We call it as the inflammation of the bronchi, that is bronchitis. And in pigs, they caused intestinal diseases. This was known. The link between these pathogens remained hidden until 1960s. So 1912 and 1960s. So this is something which is quite interesting. Up to 1960, it was all hidden. Later on, it was the researchers of UK and US where two viruses with crown-like structures causing common cold in humans were isolated. They caused common colds and they had crown-like structure. Scientists soon noticed that these viruses identified in sick animals had same bristly structure studded with spiky protein protrusions. And under electron microscope, somewhere in 1968, resembled a corona, a solar corona, and the name was given as coronavirus, which was in 1968. So it took long time, 1912 to 1968. It was a family of dynamic killers. This is something which is very interesting. For us, what is important is we call it as a dynamic killer. Dynamic killer for the reason that what it kills keeps on changing. So dog coronavirus can harm cats, and cat coronaviruses could harm pigs even. So it's a dynamic nature. It's not like a dog coronavirus will always have infection in dog. So this is the worst part. Just imagine if these animal coronaviruses will all harm humans. So it would be really very devastating, that coronaviruses caused only mild symptoms in human because they were initially associated with common cold in human, which takes around 4 to 5 days to get cures. So this is what was thought until the outbreak of severe acute respiratory syndrome, that is SARS, that was in 2003, which revealed how easily these versatile viruses could kill people. Common cold viruses, they rarely kill human, they get cured, we get cured of our own, but the same was thought here, but that does not happen, which was known in 2003 with the development of SARS. Now from 2003, let us jump on to 2011, and we see that now we have got a novel coronavirus of 2019, and see what havoc it has caused, which each one of us can now very, very clearly witness. Very clearly we can witness all these things. So this is what we basically get in here. Well, there are some facts which we would like to know about the virus. The very first is, of the viruses that attack human, coronaviruses are big. Big in terms of size. Please remember, big in terms of size. They are around 125 nanometers in diameter, relatively large. So we call 125 nanometer, which is almost ultra microscopic, and still we call it as large. So with this, one can always remember that other viruses which we are speaking of are much less than 125 nanometers. They use RNA to replicate, and the group that accounts for most newly emerging diseases. But coronaviruses really stand out for their genomes, especially the life science researchers and students and teachers. Coronaviruses really stand out for their genomes. The genome is quite stable. This is something which is really very interesting. The genome is quite stable. What does it really mean when we say the genome is quite stable? See, when we have the other viruses that infect us, and then what happens is these viruses, they usually enter into our body and they adapt to our body. They adapt to our body, thereby their virality, their efficiency to cause the diseases will be reduced. So they'll compromise between our system and their system. But the genome of coronavirus is stable, it remains as it is, so it will keep on causing damage for which it is destined. So this is what is something very interesting about its genome. With 30,000 genetic bases, coronaviruses have the largest genomes of all RNA viruses. So RNA viruses is a family of viruses. It's a big group of viruses. And in this group of viruses, if we see, we have this particular virus, which will be having 30,000 genetic bases. Mutation to adapt the host not yet seen. Hence, its weakening is slow. Mutation to adapt to the host. So once the host will always adapt to the host, and it will live on a principle called live and let live, for which adaptation is important. But here, the adaptation which is due to mutation is not seen, and hence its weakening of the virus is slow. The next point is their genomes are more than 3 times as big as those of HIV and hepatitis of that of influenza virus. So their genomes are big, so they are stable, and mutations with a very less rate, and so their virality remains as it is. And the next point in this fact finding is coronaviruses are also one of the few RNA viruses with a genomic proofreading mechanism. Now, this is a wonderful mechanism for the virus, of course, which largely disturbs scientists and researchers. Okay, so what is it basically? It's genomic proofreading mechanism, which keeps the virus from accumulating mutations that could weaken it. So no sooner a mutation is formed in the virus has its own inherent proofreading mechanism by which it will repair the mutation. And if it repairs the mutation, there is no accumulation of mutation. If there is no accumulation of mutation in it, the virus will be delayed. This ability might be why common antivirals like ribavirin, which can thwart viruses such as hepatitis C, have failed to subdue SARS-CoV-2. So ribavirin, which is a drug used against hepatitis C, cannot be used against SARS-CoV-2, maybe for this basic reason. The drug weakens viruses by inducing mutations. But coronavirus has a very good proofreading mechanism. And for this proofreading mechanism, it won't allow the mutations to accumulate, thereby keeping itself pretty strong. And if it keeps itself strong, it's going to be difficult for us to get rid or fight back this virus with medical perspective. So let's move onwards. So what we have is integrated approach to combat. For this integrated approach, there are first few 4 to 5 slides, which will go quite fast because this is something the media has been bombarding us with, but these points are really very important. What is this novel coronavirus and COVID-19 pandemic? A novel coronavirus is a new coronavirus. This is really important, new. Because it is new, many things about the virus are not known. And that has not been previously identified. Previously means it was not identified before the last week of December 2019. The virus causing coronavirus disease to 2019, that is COVID-19, an abbreviated an acronym, is not the same as the coronavirus that is common to human and cause virus is not like the other coronavirus which causes common cold. It causes something which is really severe. COVID-19 is a disease caused by the severe acute respiratory syndrome coronavirus. Hence, we call it as SARS-CoV-2. The disease was first identified in Wuhan, China in December 2019. I hope one and all are quite aware of this. The next point is, how does the infection spread? Simple droplet infection, human-to-human transmission via respiratory droplets, and contact through surfaces with presence of these viral particles. What are the clinical symptoms? Symptoms appear 2 to 14 days after exposure of the virus. A person gets exposed to the virus, means a person gets infected, challenged by the virus, and then it will take around 2 to 14 days for the person to show the symptoms. The symptoms have been mentioned here, like cough, breathlessness, difficulty in breathing, fever, chills, muscle pain, body aches, sore throats, headaches, loss of taste, loss of smell, fatigue, and few other symptoms are continuously getting added day by day. So 3 more were added by the CDC, that is the Center for Disease Controls USA. So likewise, because we have earlier made a statement that this is a new virus, so many things of this virus are not known, and so we will have to be very much aware about all these things. So these are few concepts that one has to know about the virus. Who are at the risk of COVID-19? So let us see who are at the risk. Though age is no criteria for getting infection, but elderly people, that is an age has been given here. Now this age of 60 years, but at places it's even considered between 58 to 62, 64. Okay, having some underlying systemic diseases are at high risk. This statement is very important. People with underlying, people in whom the immune system is already challenged will be really at risk. So like people suffering from diabetes, blood pressure, heart patients, asthma, or have renal failures, people who are on dialysis, etc., those who have got compromised immunity will be easy victims for this virus. Can this disease or infection be prevented? This is something the entire world is thinking of, be it scientists, be it the Gentiles, be it the politicians. Everyone is thinking of this. Let us see. The very first point seems to be quite discouraging, making us nervous, but well, time will speak for itself. No vaccine has been developed as yet. However, some medications are found to be effective. No vaccines have been developed as yet. But let me tell you, research on development of vaccines is really going on at a real high pace. And people are claiming to come out with a good vaccine in next 4 to 5 months even. Good immune response fights the infection better, and many suffer with lesser intensity, and chances of recovery will be better and sooner. So please underline this: good immune response. This is something which is going to be integrated into our title. Though all other precautions like mask, washing hands frequently, maintaining physical distance are of importance and should be adhered by all means. These are the only ways by which we can prevent the infection as on today. What is the success rate of the treatment? Again, not so good to hear, but most of the patients get well by themselves within a few days. It's not all, it's most of them. Many patients remain asymptomatic despite being tested COVID positive. Asymptomatic patients don't have problems as such for themselves, but can always of infection in the community. The patients with challenged immunity due to several other factors suffer a greater deal. Challenged immunity is something which is really common these days. Respiratory or cardiac symptoms like ARDS, acute respiratory distress syndrome, fibrosis of lungs or thrombosis, multi-organ failure usually leads to death. These are the symptoms where death is quite common, and hence the rate of death is somewhere around 2% on an average, while people who get recovered of themselves would be somewhere around 80%. So this is something good, but again, the remaining 20% are someone with whom the society is associated. So what we want for the well-being of the society is not most of, but all of the patients should get well. The next one we have is, what about alternative system of medicines? Do they offer some effective treatment? Since it is a new disease and there have been no specific medicines or treatment known, though there have been literature available which confirm the very effective role of homeopathy treatment during epidemic of Spanish flu in 1918. So this is something, when we are speaking of alternative system, we are speaking of a system other than allopathy. And other than allopathy, we have a history, something mentioned in our history, that was of homeopathic treatment of the Spanish flu somewhere in 1918. The next one, what we have is, how long will the coronavirus last? A question that really matters all of us. Okay, so it's too soon to tell how long the pandemic will continue, because I think on 29th of June, the Director General of WHO said the worst is yet to be seen. It's not that things are getting declined. The graph is not really coming on to a plateau. And once it reaches a plateau, then will be the phase of decline. So it's too early to tell. The next one, it depends on many things, including researchers' work to learn more about the virus, their search for a treatment and a vaccine, and the public's effort to slow the spread. So these three lines speak a lot about how long the coronavirus will last. The last point is the public's effort. So what are the efforts that we take? This is indeed a question for us today. Let us take this question with us and try to give or try to answer it each day of our life to come. More than 100 vaccine candidates are in various stages of development and testing. Bharat Biotech is in news for last couple of days, and they are saying by 15th of August, we will come out with a very good vaccine. Let's hope for the best. The process usually takes years. This is in normal course. Developing a vaccine takes years because there are clinical trials to be taken, toxicological testings, short-term testings, long-term testings on the various vital organs. Everything has to be done before a molecule is introduced as a drug or medicine into the community. And so it takes years. Ideally speaking, somewhere between 15 to 20 years. But researchers are speeding it up as much as they can, but it'll still take around 12 to 18 months, as it is said by WHO. How contagious is the coronavirus? Well, again, the figures speak quite boldly. The transmission rate is relatively high. This is something which bothers us. Early research has estimated that one person who has it can spread it to 2 to 2.5 others. But the other study has found it spreading between 4.7 to 6.6 others. By comparison, one person who has a seasonal flu will pass it between 1.1 to 2.3. So see, seasonal flu, as usual, as I have said, discussed earlier, this is something which is common and it gets cured within 4 to 5 days. And the spread is just between 1.1 to 2.3%, but here it's between 5 people. We can work to lower the transmission rate by washing hands and good hygienic practices, keeping common surfaces clean, limiting the contact with other people, wearing face mask when we can't stay 6 feet away from other. So this line speaks when to use a mask. The next point we have is diagnosis. Let's not speak much about it. So basically, if a person has anything of this, like temperature, cough, breathing problems, only then testing for corona would be done. Swab test, which we all know is taken, rapid tests are available, RT-PCR method is used, antigen testings. So all these things are used these days to get a rapid report, a report within 1 day, a report within few hours. And this is all to save the community. Corona prevention. Again, very simple. Washing hands is important with an alcohol-based sanitizer. There are many sanitizers which are really not good, should not be used because they won't kill the virus. So using a good quality alcohol-based sanitizer is important. Then practice physical distancing, and then some common healthy practices. In addition to that, we have two terminologies: quarantine and isolation. Quarantine, keeping someone home and separated from other people if they might have been exposed to virus. There's a likely chance. So you quarantine them, you keep them aloof, keep them separated. Isolation, keeping sick people away from healthy people, including using a separate sick bedroom or bathroom when possible. So isolation is usually done under some medical assistance even. Now let us go back, come to this point, that is integrated approach to fight back coronavirus. What is it that we can do to fight back this coronavirus? So Corona-19 pandemic has adversely affected every human on this planet. This is an interesting terminology which I came across. Amidst infodemic of healthcare blogs and expert comments, it is difficult for a common person to decide the correct prevention protocol of COVID-19. Infodemic. These days, because of COVID-19 pandemic, havoc and confusion and chaos, so much of information is being bombarded that we are getting a condition called infodemic. So on your WhatsApp and social media group, you get so much of information that a person can get easily confused of what to do and what really not to do. Being a new virus, there are challenges to prevent and cure this disease, which is most important point. The last point here is on this slide is again quite interesting. COVID-19 poses a low threat at individual level and high risk at population level due to low pathogenicity and high infectivity. Though the pathogenicity is less, as we have said, 80% of the population may not get, the most severe of the symptoms of COVID-19. But yes, the infectivity is really very much high. And you do not really know in population which 20% are going to be seriously affected by the disease. Then we have the next point, that is COVID-19 crisis needs comprehensive approach. One straightforward approach may not work. We need a comprehensive approach. Appropriate self-care for disease prevention at individual levels can stop transmission of diseases in the community. This is important. Self-care for disease prevention. This is really very interesting. Once it is done at the individual level, only then we can have things preventing the spread. Allopathy, Ayurveda, or homeopathy to be used in integration. Few medicines in all these categories are known. I have deliberately avoided to put the names of the medicines under each category on the slide to avoid further infodemic, but well can easily be done. Lifestyle to be thought seriously and modified if required. Self-care, appropriate self-care of the disease prevention is related to lifestyle. So we'll have to think on our lifestyle once again. We'll have to think on what to do and what not to do. Hello?
Hello,
Yes?
sir. SARS is known but South Asian Regional Cooperation, sir. It's otherwise. Am I right?
Hello.
Hello, sir. Can you hear my voice?
Yes, yes.
Sir, SARS is known but South Asian Regional Cooperation
Well,
Organization.
that is a geopolitical group. That is something different, and
Yes,
this
sir.
is something different. The
Yes, sir.
acronyms to some extent match, but that
Yes,
is
sir.
a geopolitical area, and this is a purely medical area.
Yes, sir.
Okay. We'll take all the questions. You can even put your questions in the chat box. Not an
Yes, sir.
issue at all. Yes, yes,
Yes,
yes.
sir.
Public awareness in the right way. Public awareness in the right way is again very important. For public awareness, each one of us, I hope on this webinar platform, most of us are academicians or related to academics, wherein public awareness is something which is expected from us, and we should be at the forefront of public awareness system. So these are few points. Then we have physical distancing, most important, personal hygiene and cleanliness measures. Now this is important, non-specific virus hostile environment to create local barriers are important. Virus hostile environment to create local barrier. Now the terms seem to be quite heavy, but it's very simple. Speaking in simple terms, we are speaking of integrated approach. Now let us go back to the terminology: self-care, then lifestyle, integration, okay, personal hygiene, cleanliness will all be related to a healthy mucosal concept in our body. The mucosal health, that is, mucosa is the layer of our respiratory system. On the respiratory system, we have got n number of cells which have got some cilia. These cell lining has to be quite healthy. It can be healthy provided we take care of each and every of this. Example of lifestyle. If you keep on unwanted junk foods, it is going to affect the mucosal health. That is going to be very, very interesting. If you do not take proper rest, if there's no proper exercise, it is going to affect the mucosal health. The stress is known to affect the mucosal health. And if there is a problem with the mucosal health, then infection of the virus and further strengthening of the disease is going to become more easy. So one will have to take care of all these things in an integrated approach. So this is really something very important. The next point, we have a strong immune system for strong systemic defense. We need to have a strong immune system, and the strong immune system will be important. Strong immune system will be important for a strong systemic defense. We will have to defend ourselves from the virus. Defending ourselves from the virus is totally attributed only to our immune system. In the earlier slide, I spoke of mucosal health, which becomes a concept of innate immunity. If our immunity is perfect, we can offer a strong defense. So that is really important for us. So only if we have a strong immune system, we will be able to defend against the virus. Now, what does it depend on? The strength of immunity depends upon, of course, genetic composition. That is the first point, which unfortunately we cannot modify. Second, nutrition. Third, mental health. And fourth, environmental factors. Please remember, these are some most important cases: nutrition, mental health, environmental factor all be related, will all be related to our we do, what do we practice, is all related in building up our immune system. Let me tell you, reading good produces good hormones and good communication in your body, and so you act good. And so it is said, a man is known by the company he keeps. So your body immune system will also be known by what sort of lifestyle you keep. And that is really very important for us. The next point we have is lifestyle modifications. Lifestyle modifications, pets and reservoirs like bats and rodents. Take care of this. Pets is something which is very common. If you remember, in the very first few slides, I did speak of what is called as dynamic killer. It is the dynamic killer. This coronavirus, which we are experiencing from 31st December 2019, is a dynamic killer. It is not meant to kill or attack or infect only one type of host. It can be found in other animals. And so when we have pet, we have to take proper care. There are natural reservoirs of these viruses. You know, dozens of serious viruses are associated with bats. And if they are associated with bats, these bats are again quite commonly associated with our gardens, and they can easily be coming into our houses like rodents do. Second modification required is nutrition, rest, exercise, and this is something very important, optimum hydration. This is not largely spoken of, but let me tell you, optimum hydration is really the most important factor for good mucosal health. And if you want to have a good mucosal health, you need good optimum hydration along with some vitamins, like you have the vitamin C or few vitamin of the group B. The next we have is maintaining health services and critical infrastructure. This is, of course, at community level, at government level, that in the integrated approach, maintaining healthy services is maintaining health services and critical infrastructure is again academicians. This is again an important point for us. Value education with respect to health aspects at all the levels are really important. We will have to take care of each and everything that is encompassed under health well-being. So this is all an educational or higher education institute will have to take care of. The next one we have is, see, there is no specific treatment for COVID-19 as on today. If you read today's newspaper, I am speaking of the Pune region. There's a news of this medicine which I have highlighted here, remdesivir, and there is a shortage of this medicine right now. We are yet to see the worst, says the Director General of WHO. And right now, if we are short of such things, it's going to be very difficult. People who get mild case need care for the symptoms like, you know, fluids, fever control, etc. Take over the counter medicines for a sore throat, body aches, fevers. So that is fine. Antibiotics are not going to help because we are fighting against viruses and not bacteria. Antibiotics are designed against bacteria. People with severe symptoms need to be taken care of in a hospital where you require all proper medications. Many clinical trials are underway and explore treatments used for these conditions. Several studies are focused on antiviral medications called remdesivir, which was created to fight the Ebola outbreak. Clinical trials are also underway for a drug called tocilizumab. Now, this is again quite expensive. But again, we are trying our best to get this medications. New medicines are being claimed for their effectiveness against the virus or either being included in the category of immune boosters. So this is again one more point we'll have to take care of. Now, this is something which we will have to focus on, that is critical forward thinking. This is an important approach to combat COVID-19. Critical issues that need to be explored in managing the cases. What are they? The very first point, what is the effect of long-term shutdown on mental and physical health, including livelihood and economy? We need to have a golden mean between health and economy. That is a pressing need of today. And taking that into consideration, designing combat strategies are going to be quite challenging, but one will have to do it. You know, there are people who say when the cases of COVID-19 were really very less, we had a very strict shutdown or lockdown. And now when the cases are increasing, why is it that we are going on for unlock? The only reason is to get a golden mean between health and economic status of the state. Immediate impacts at the primary, that is individual level, including food, nutrition, shelter, livelihoods, will have to be thought of. We have all witnessed the migration concept, especially in a state like Maharashtra. And then we have seen several, self-help groups and NGOs coming forward for food, nutrition, and shelter at individual level. Most of us, we have helped these people. So these are again an integrated approach. Variations in health service capacity within the state or region, major cities versus rural health services. Again, this is going to be quite critical. In major cities, you will need to have a different strategy. And at rural areas, we need to have a different strategy. Out of curiosity, let me tell you, there was an news on the television in a particular area, I won't name it. A person self-quarantined him on a treetop. So that was possible in a rural area. The thinking, the way it is thought of keeps on differing. The next aspect of this critical issue is ensuring that routine care, particularly elderly care and vulnerable people, will keep on continue. We cannot entirely divert our medical forefronts only on COVID-19. In addition to COVID-19, routine care and elderly people care, vulnerable people will have to be given proper attention. So a strategy for this needs to be properly devised. Plan for other routine health services such as management of long-term conditions, cancer, heart diseases, other critical illness should also be taken care of. If you read newspaper, neonatal and maternity care, you can see articles written on all these days. So we'll have to take care of it. No one size fits all. Global guidelines, measures needs to be adapted to fit social norms and practices. Take a country like India. The central government issues a guideline, and lastly, they say a state has all rights to modify it as per their needs. And so we say no one size fits all. Yeah. Let us see the other critical issues. preparing for a second, third, fourth wave of supporting surge capacities. We hope there is no third and fourth. Second wave is being experienced by few countries. Preparing flexible transition strategies, including transitioning between public health measures. This could include loosening and reapplying restrictions depending on how the situation evolves. Restarting economic activities important for livelihoods and businesses. Managing emerging pockets of diseases. Preparing vaccine strategies. Preparedness for such instances in future. Such is something similar to COVID-19. COVID-19 is just one virus of the billions and billions of viruses on the face of Earth, which has disturbed over 216 countries to be precise. Just think, if COVID-19 is supplemented with one other virus, what would be our state? And so we will have to be on our toes to face such instances. As per the WHO, we have got an act. And what is this act? It is Access to COVID-19 Tools, which is abbreviated. The acronym is ACT. Accelerator. So the ACT Accelerator is a new groundbreaking global collaboration to accelerate development, production, and equitable access to COVID-19 tests, treatments, and vaccines. So upon these 6 months or so, a period of around 6 months or so, we have got a global need to collaborate for tests, treatments, and vaccines, which has been given a name ACT. So one will have to think a lot about this. And what is it? Accelerator brings together governments, scientists, businesses, civil society, philanthropists, and global health organizations together. There are 4 pillars of ACT. What are those? First, diagnostics. Second, therapeutics. Third, vaccines. And fourth, the health system connector. In addition to the cross-cutting work stream on access and allocation. These are the points which are today being thought of at global level. We, being a part of Higher Education Institute, will have to put in ourselves somewhere in this 4-pillar constituency and share or contribute our giving back to the society. Now, this is what is a brief summary what has been noticed over COVID-19, that is unknown cause, Wuhan, 31st December 19. Then 4th January, WHO reported what? A cluster of pneumonia cases of unknown reason, okay, with no death. The next one that we have in this case is the outbreak was declared a public health emergency of international concern on 30th January 2020. Please remember, the world was awake since 31st December 2019. WHO intervened just 5 days, effectively on the 5th day of this unknown cause or case. The outbreak was declared public health emergency on 30th of January. On 11th February, WHO announced a name for the new coronavirus disease, and the name was COVID-19. On the 12th of March 20, WHO declared COVID-19 a global pandemic, covering more than 3 regions as per the WHO norms, geographical regions. Since early March, countries around the globe have been introducing more severe measures in an effort to control the spread of the disease. Measures included from March onwards, where physical distancing, closing schools, restricting travels, restricting imports, and such, which even we have witnessed from the 17th day of March 2020. Almost all countries in the world have reported cases, a total of 10.3 million confirmed cases. This was on 30th of June. Today, it is 10.66 million, around 2 hours back. 16th June 2020, WHO welcomes the initial clinical trial result from UK that show that dexamethasone, a corticosteroid, can be life-saving for patients who are critically ill with COVID-19. 17th June 2020, few days back, the chloroquine arm of the Solidarity Trail to find an effective COVID-19 treatment was being stopped. Vaccine development may need up to 18 more months was the next news in this area. And now what we see these days, in addition to all above, we see unlock that has been started variably. So this is all to find a mean. And then we have a wonderful statement which I came across. And what does it say? What does it say is, when a COVID-19 vaccine does become available, it should be treated as a global public good. To that end, we are both calling on all governments to ensure that the outcomes of publicly funded COVID-19 research are affordable, available, and accessible to everyone around the world. So now people are saying that if at all you design, discover a vaccine, let us make it a global public good so that the entire global society will take care or will be taken care of with this vaccine. And with this, I would like to end my talk saying, stay home, stay safe. Thank you. Thank you very much.
Well, sir, finished?
Yes, sir. Yes.
All right, sir. Thank you so much. It was for quite a long time that you stretched your topic and were very informative.
Thank you.
So shall we call for some questions?
Yes, of course.
Dear participants, if you have any questions, you are free to ask. Sir is ready to answer the questions. Anyone? Only one at a time.
I think
Yeah.
giving
Hello?
answers to the questions asked on this new topic, even asking questions is
Sir.
going to be a challenge.
Hello?
Yes, please, please. Yes.
Hello,
There's somebody.
hello,
Yes.
sir.
Hello?
I want feedback link, sir.
Hello?
Oh,
Hello.
yes.
Sir,
I
I'm
wa-
audible.
Yeah, you are.
Sir, my name is Maheshwari Purushothaman,
Yeah.
Assistant Professor from Wales Institute of Science, Tamil Nadu, Chennai.
Yes.
It was a fantastic and informative session, sir.
Thank you.
Thanks a lot for giving us such humorous information regarding the COVID.
Thank you.
And my question regarding this COVID is, actually, when I was able to see about the news, they have given that the new vaccine will be ready by August 15 from the
Yes, by August
ICMR.
15.
Yeah. Is it so, sir? It will be very useful for us?
See, there are two aspects basically. Speaking on a normal ground, any new molecule to be introduced into the human market of medicine should be tested very religiously for short-term and long-term effects on human health. There are several medicines which are good to combat a particular illness, but they may have a serious effect at maybe after 7, 8, or 10 days on some other aspect of it. as it is quite commonly seen in steroids. I did listen to the news of ICMR with Bharat Biotech saying they are ready with the trials. The trials are going on, and they will be ready with a vaccine by 15th of August.
Yes, sir.
But there
Yes.
was a question mark on it. I mean, I'll welcome the statement that if they are really ready by 15th of
Yeah,
August,
it was
so
something a
that
boost for us, na?
yes, that will be a very good boost. That would be a life-saving discovery on our national development concept. So this should work out, even if it is available, or even if it is designed by 15th of August. I'm really worried about, like, at what point in time it will be ready for sale in the market.
Oh,
Designing
that's,
is something different. Research is something different. You
yes, sir.
get
Yes, sir.
some good results. You test it on laboratory model organisms. Maybe you have some clinical trials initially, but then bringing it into the market is again going to take some time. But I'm very sure ICMR, which
Hmm.
has been on its toes against this disease, will really come up with a very nice vaccine or medication in this aspect. Thank you.
Yeah, actually, we also praise, sir, because we have to get the
Yes,
vaccine.
yes,
It's
yes,
really a very dreadful thing for the
yes,
whole global pandemic. What you said is right, na?
yes.
Really, the whole world is worried about it.
Right, right. Thank you, thank you.
Thank you for so much of information, sir. I take this gratitude and also an opportunity to the convener and also to all the organizers of the team for giving me an opportunity to talk to such a highly informative resource person like you. Thank you, sir.
Thank you so much.
Yeah, sir. And thank you, organizers also. Thank you, sir. Thank you.
Some Aishwarya More wanted to ask question.
Sir,
I could
hello?
see a raised hand by Aishwarya More
Yeah, yeah. Okay,
asking
sir. Sir.
next question, yeah. Or anybody else for that matter.
Hello.
Hello.
Yes, sir. Can you hear me?
Yes, yes.
Yeah. Good afternoon, sir. Every day, my question is every day nowadays information is added to our knowledge through news and social media. So
Yes.
my question is, how long does this COVID-19 virus remain on our body, or even our hair, or does it transmit it through eyes? There is controversy regarding this. That is why I'm asking this question.
Yes, that's a very good question. That's a question which should really bother each and every one of us. Well, under laboratory conditions, tests were taken for the presence of this virus in an active state on various surfaces.
Okay.
This virus remains active variably on various surfaces.
Yeah.
Of
Okay.
course, when it is cotton, I mean to say the fabric and all, you can always get it in an active phase over there for at least 1 to 2 hours, 2 days.
Okay.
It can very well remain on the hair, provided there's no oil on the hair, which is
Yes.
quite common these days.
Mhm.
Because if at all it's coconut oil has got its own inherent good bioactive potential, which would not allow this virus to strengthen further. And when we are speaking of eyes, when we are speaking, see, eyes can be considered as a point of entry. It's this virus particle, as discussed earlier, is around 125 nanometer on a scale. But we do have our immunity working in our eyes also in the form of tears. So we
Okay.
do have, that is what I was just speaking of earlier, speaking on the mucosal health. As long as our mucosal health is proper, we can very well take care of this virus. And so remaining optimally hydrated is something which is really very important. One has to take good amount of water every day. You should have a good supplement of vitamin B and vitamin C, because that helps
Yes, sir.
into the health of our uh, epithelial lining, and this is going to help us.
Yes, sir. Yes, sir. Thank you so much. I could
Thank
not
you.
resist to ask you this
Thank you so much.
question. Thank you.
Yes.
Yeah, participants, any more questions?
I could see.
Raised hand.
No, I could see something privately asked to me on my chat. Is coronavirus weakening or getting stronger? As there are several news of new symptoms. Well, there are news of new symptoms. Let me add to it. We know this virus only for 6 months. Judging a virus and what it really can cause, knowing everything of this in 6 months is really difficult. Second, is the virus getting weakened? If you see the fourth and fifth slide, if you recall the fourth and fifth slide of mine, I had spoke of a very stable genome of the virus. The genome of this virus is really very stable. The virus has got its own powerful proofreading activity. So if at all, when a virus enters into our body, it will try to adapt. In this, there will be, because of medicines or because of our inherent immune molecules, we may try to kill the virus, causing some sort of mutations or mutational damages. But even if a mutation is being caused, the virus will proofread the mutation. It will keep the mutation away. And if it keeps the mutation away, its genome is going to remain intact. And if its genome is going to remain intact, then it is going to be something that is called as non-weakening. It is maintaining its strength. It is remaining as it is with respect to the virulence or the virulent capacity of the virus. And with other viruses, what happens is the mutations leads to weakening of the virus. So this is what basically happens. With respect to vaccines, even the Oxford vaccine, which we are speaking of, is also quite likely to be discovered. I mean, there are quite good news coming up from the Oxford vaccine backgrounds. And there are many. As I have said, at least 100 vaccine candidates. 100 vaccine candidates are being tried and are being tested worldwide. And of this 100, I personally hope all 100 work, so that we will not be having a competition for a particular vaccine. But biologically speaking, that may not be possible. But yes, let us really have a good array of virus, a good array of vaccine to save the human society.
Well, does anybody want to ask anything more?
At this point in time, let me tell, if at all there are no questions right now, the organizers do have my email ID. You are always free to write to the organizers about your questions. I will be privileged to answer. I will, if not, I'll at least try my best to answer the questions.
Well, sir, shall we move on then?
Yes, we shall.
Thank you so much for elaborative answers. And it's my immense pleasure, sir, to express my sincere thanks to you.
Thank you.
Dr. Abhay Khandagle, sir, you were very thorough in your presentation and covered all aspects of this pandemic, which has threatened the whole world. And you took really a complete historical account and its prevention measures too. Your approach was truly like your top.
Is there an audio problem? Hello. नमस्कार साहेब. नमस्कार. 7 अकाउंट्स दिलेत. सर आपलं ते एक MCS म्हणजे कम्प्युटर सायन्सचं जे अकाउंट होतं ना, ते पहिल्यापासून वेगळंच आहे सर. नाही म्हणजे मग आपल्याला सगळेच PG एकाच अकाउंट मध्ये घेता येतील, असं करता येईल. बरं. हो.
हॅलो, संपलं काय?
नाही त्याच्यामध्ये हो हो
संपलं काय? वेबिनार संपलं काय सर?
नाही
हॅलो.
हो MSc कॉम्प्युटर सायन्सचं त्याच्यामध्ये
क्लोज करायचं काय?
आणि त्या अकाउंट मधून त्या लोकांचे हे जातात पगार वगैरे. मात्र ती जी फी आहे ती आपण
पांढरवळे सर,
पेमेंट घेतल्याने
पांढरवळे सर,
जसं मागे चर्चा झाली तसं मग त्या अकाउंट मधून PGच्या
पांढरवळे सर,
इकडे ह्या अकाउंट मध्ये वर्ग करून मग पुढचा खर्च करावा लागेल, असं
हॅलो
काही करता येईल, चालेल ना म्हणजे असं.
हॅलो हॅलो
नाही करू शकतो आपण, काही प्रॉब्लेम नाही. फक्त आता आपण जे ऑलरेडी करतो नाही असं काही आपण नक्की चेंज करू शकतो, नक्की चेंज करू शकतो.
हॅलो हॅलो हॅलो.
हॅलो सर.
हा दुसरा सेशन आहे का आता लगेच?
याच्यामध्ये त्यांचं म्हणणं एकच आहे की आपण जे आता पगार त्या अकाउंट मधून त्या
कब
शिक्षकांना
आएगा
करतो.
दूसरा सेशन?
मग आपण आता ह्या अकाउंट
हॅलो
मध्ये जर समजा याचे पैसे
हॅलो,
आपण
बोलिए
आता
सर.
सगळे PG एकत्र करून एकाच
हाँ ये
account मध्ये
दूसरा
घेतले,
सेशन होने वाला
तर
है.
मग आपल्याला ते सगळे पगार आहे त्या अकाउंट
हाँ,
मधून तरी करावे लागतील. नाही
क्या आप
तर त्या
सर्टिफिकेट
account
भेज
मधून
देंगे
ह्या
ना?
account-
हॅलो
नाही तसं
हॅलो.
काही होणार नाही, पण मग पर्याय नाही, हे
पांढरवळे
account
सर,
कमी कमी होऊन बंद होईल.
पांढरवळे
पर्यायाने
सर,
हा मग
पांढरवळे
काहीच प्रॉब्लेम नाही साहेब, बंद म्हणजे ओके ओके ओके.
हॅलो पांढरवळे सर.
नाही 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 असं नाही असं नाही. ओके मग मी याच्यावरती सर उद्या
हॅलो
साधारणतः
होस्ट
8:30
S.M.Joshi
पर्यंत
कॉलेज.
फायनल देऊ शकतो.
हॅलो होस्ट S.M.Joshi कॉलेज. हॅलो होस्ट, सो यू अनम्यूट युअर माइक. डॉक्टर पांढरवळे सर. हॅलो
Sir, no one is there, I think.
हॅलो डॉक्टर पांढरवळे सर, आर यू लिसनिंग? डॉक्टर पांढरवळे सर. हॅलो खंडागळे सर.
Professor Phil, are you there?
खंडागळे सर.
Yes, I'm here.
Yeah, welcome back again. Yeah, this is Rashmi.
Oh, thank you. Be back there again.
Yeah.
नाही मी साहेब मी त्याच्यामध्ये काय करतो, उद्या मी सकाळी गेल्या फक्त तेवढं सगळं काढतो आणि
हॅलो
त्याच्यातून त्याच्यामध्ये टाकतो.
हॅलो
हो हो हो.
तुम्ही ज्या व्यक्तीला कॉल केला आहे तो दुसऱ्या कॉलवर व्यस्त आहे.
स्टुडंटच्या डॅशबोर्डवर आहे. हो हो बरोबर.
हॅलो होस्ट S.M.Joshi कॉलेज.
हो हो.
हॅलो एनीवन लिसनिंग? हॅलो डॉक्टर पांढरवळे सर. Please unmute your mic. Dr. Pandarbale, sir. Hello, anybody is there? Hello.
Hello.
Who is speaking?
I am from Vellore.
Okay. So you are the participant, na? I am also participant.
Yes, tell me.
For example,
The host is not responding to our call. Hello.
Okay, then you mail him.
Oh.
Hello, Dr. Pandarbale.
Okay.
Sir.
म्हणजे आपण जीवनला मॅप करू शकतो X अकाउंटला, G2 ला Y अकाउंट.
Hello.
नाही सर, मी काय करतो
Let us wait for organizers.
Hello. Amir. Hello, anyone is there? Hello, are you listening my voice?
Hello, sound please.
मी करतो सर, मी करतो. येस मी करतो आणि मग त्या हिशोबाने आपल्याला मॅक्सिमम म्हणजे या ग्रुपला
Anyone is listening there?
Yes.
Sir, let us wait for organizers, sir. Let us wait for them.
Okay. Then what about the next section?
We'll be having the next session in 10 minutes. That was the message on the group. So I think we all have to wait for next 10 minutes.
Okay.
Is it so? Yeah, okay.
You want?
$1 crore.
Hello?
1 crore.
खंडागळे सर.
येस सर.
ते रिस्पॉन्स देतात का तुम्हाला काही?
हॅलो.
नेक्स्ट सेशनच्या बद्दल काय रिस्पॉन्स दिलाय त्यांनी तुम्हाला?
Yes, sir. We are starting in 2 minutes.
Okay.
Our next resource person is from US. We are just checking according to his time. It's very early morning.
Oh.
So let's take his availability, and soon we are going to start. That's what we announced a break for 10 minutes.
Okay.
And then, sir, we will start soon.
Fine, sir. No problem. Yeah. Hello. Hello. Hello.
Hello, sir.
I think we should start with the session.
Yes, sir.
Hello.
Hello.
Yeah, we are trying to connect to Philip Kohler, sir, from USA. Just a minute. He is online.
Okay.
He's
Okay.
online. Coming. We are joining him in the meetings.
Okay.
Okay,
Okay.
sir. Okay,
Soon
sir.
we'll start. So sorry for delay, but
Okay,
please,
sir.
please be with us. Just a minute.
Sir, what time about next section, sir?
Yes, just a minute, sir. Just a minute. We have a resource person from abroad,
Yes,
and
sir.
he joining. We are admitting him. Soon we are going to start.
Yes, sir. He is from which place, sir?
He is from USA.
Yes, sir. Yes, sir.
Yes.
सेकंड होस्ट कनेक्टच नाही होते USA वरचे ते फिलिप कोहेलेकर फिलिप कोहेलेकर फिलिप कोहेलेकर
फिलिप खोलर काळे
लावा झाल्यावर प्राचार्य प्राचार्य झाल्यावर होय हे काय नाही पडलं तुमचं हा एक 58 मग ते पडला एक 58 आम्ही जेवत होतो आणि पण झोपाय गेल्या बघितली आणि जास्त झोपायचा वाटली झाला असं पडला मग केलं वय नियोजन आला पडा चांगलं झालं की दीक्षित सर आहे का तुमच्या सोबत आला 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 भारीच काम हा हा यशवी गायकवाड मंगळवारी डांगे असा माने मस्टर नाही
पहिल्या दिवशी माझा 5वा नंबर आहे
1 2 3 4 5
आजचे 2 सायन्सची 3 आम्ही बरोबर करत आलो मला दिवशी जायचं होतं
गाडी कशाने आलं तरी
सोमवारी म्हणले रात्री म्हणजे ती कार्ड म्हणजे मी ह्या सोमवारी नाही आला तरी तुमचं बघू आपण तिच्या पुढच्या सोमवारी म्हणले नाही त्यांना फक्त एकट्याला सोड दिली तरी म्हणजे 17 दिवस होता बघा तुमचं अगदी वाढलं नाही आला तरी चालतंय
16 participants. Well, participants, hello? Can the participants respond? Hello? Hello? But they can unmute themselves. है ना madam? Unmute करून बोलू शकतात ना? Hello, all participants, please take a note. We deeply apologize. We cannot continue with the session now.
Hello.
Hello, ma'am.
Yes. Yes.
Yeah. Do you get me?
Yes, sir. I can. Hello. We can hear you.
Yeah, ma'am. The difficulty is that I sincerely apologize that the resource person from Florida University is unable to join us.
Okay. So
We
we
tried several
won't have.
times, but we couldn't join. Now we have come to the conclusion that we will reschedule this session to some another day, but we have to take his consent.
Okay.
As soon as we receive his consent, we will put the announcement on the Telegram channel and you will let you know the next fresh date.
Okay.
Fine?
Sir. Thank you.
Meanwhile, we sincerely apologize from the S.M.Joshi College Zoology Department. Keep patience for some more days and we will definitely conduct the session.
Okay.
Thank you, sir.
Thank you, sir.
Thanks a lot.